everyone. Today I want to tell you about topic alternating current. We can divide current flow um, two different ways. It's direct current and alternating current. Direct current is a current that usually don't change its value and don't change don't doesn't change its direction. So its flow only to the one way. And alternating current changes its direction all the time, and um, the we can say this number that shows us how often the alternating current changes its direction called frequency, uh, and the time after uh, the amount of time after which we have current goes the same way, so it repeats itself, called period. We will not only talk about that, because today I don't have some special paper and markers to show you the details, and I will show details on my notebook, and that's it. So we will not only talk about that, but we will see some details on the paper. Let's go. So here you can see is my notebook. Yes, not notebook like this, but notebook like paper notebook. Yes, and we can write down our topic: alternating current. So what's more? Yes, so what does it mean alternating? So we can provide, for example, a plot, first of all, for direct current. Direct current, we also have this abbreviation or this short title as DC, so it's direct current. Yeah, that's it. So direct current we can show like this. Here will be, for example, current. Yes, here will be time, and so direct current is some amount of current that does not change, but in fact it could change somehow. We don't know how, but it can be any function. Yes, um, but mostly when we talk about direct current, it's the current that does not change, and we want to make this current looks like that, and somehow um, to make something with our not very beautiful function and to make it more beautiful and more direct, more straight. Also, we can talk about voltage, and when we usually talk about voltage, so voltage is same. It's um, I don't know, V first, for example. So we have the same voltage each second. Yes. When we speak about the alternating current, we usually draw like this. So we have um, such a plot. We have also time, and time is important. Yes. So for us, for direct current, we should say that if it is the same amount each second, we don't need even to draw this plot. But when we have alternating current, we also can write down it as AC. Yes, so we have it looks like that. So uh, you can also understand that here is sinus graph. Sinus. It can also be a cosinus. Cosinus when we have just a time shift. So the main idea is that the perfect alternating current will work like sinus. That's it. And we can also say that here will be the amplitude, and here we will have the peak voltage. So it is voltage peak, and minus voltage peak. So here minus does not mean that we have really voltage below zero. It means that voltage changes its direction to another direction. So it means not in even I did not explain it good enough. So it does not mean that voltage really changes direction. It means that current changes the direction. So for example, we have something like this. Yes. Uh, so here will be, I don't know, some resistor, and here we will have a alternating current power supply. So first of all, current will go this way, yes, and then it will go another way. So that is the idea. Yes, so current goes this way, and then it goes another way. And it's changed its direction all the time. And also, not only direction, but the amount of current, yes, and so the amount of voltage as well. Here, what can we understand more? We can see that the signal, yes, make this a circle, and then from this point, yes, as it starts from this point, and here is the same point. So the signal continues and it repeats itself. And that means that um, this time, yes, this amount of time, I can say, is important for us. And this amount of time called period. So T is period. Period of time that is needed for voltage to make a full circle. That's it. And we also have such an important thing as frequency. Frequency. Yes, frequency. What does frequency mean? Frequency is called F. Yes, in our language, in Russian, in Belarusian, usually we use another letter. We use nu. Yes, Greek alphabet nu. But as far as I understood, in English version, we use just F from the frequency, and it's 1 divided by T period. So it means that how much circles we have in amount of time. It means that we have just one circle in amount of time, which is period. But we also can write it down as here, for example, f. For example, we have this amount of time. Yes, so this amount of time can be just t2, for example. Yes, so it's t2 amount of time, and we have two circles, 1 2, so it's the first circle, it's the second circle, so we can also divide 2 by t2, yes, and it will be the same as 1 divided by period of time. Yes, so we can understand it like that. And usually this amount of time, yes, period, it's more usually used than, so frequency is usually used. Frequency is used rather than period. But we can easily count period of frequency when we know one of it, I can say, yes, one of these amounts. That's it. Great. So what's the next? Also very important, yes, very important thing is it is called RMS number. RMS means root mean square. What does root mean square means? It means that we have another parameter. Yes, we call it RMS. And we can find it as V peak divided by square root of 2. Yeah, and it will be an amount somewhere here, I can say, yes, or somewhere here when to take it with minus. Yes, so here will be VRMS and here will be minus VRMS. Yes. So what does this parameter mean? We use it to count something like average amount of voltage that is coming when we have alternating current. And this average amount of voltage gives the same effect as we have, for example, just the same voltage with direct current. So we can something like exchange alternating current circuit, yes, with some amount of RMS to direct current circuit with voltage, yes, constant voltage that will be exactly RMS. So that's it. Yeah. And what can we talk about more? Yes, we talked a little bit about just direct powers, direct current power supply. We talked a little bit about alternating current, yes, and we can understand more how it works when we have alternating current, yes. For example, how different devices understand it and use it. Yes, we can say like this. Try to focus my camera, that's it. So, for example, we have alternating current. Yeah, and it means that, for example, yes, our kettle I need to use, for example, here peak is 5 voltage, and so here is minus 5 voltage. Kettle needs only voltage of 4 volts. Yeah, so 4, for example, somewhere here, and minus 4, minus 4. So what does it mean? It means that kettle will work only in these periods of time when the voltage is more than 4, yeah, goes more than 4. And here, when the voltage is more than 4, so minus doesn't matter for us. Minus means only another direction of current, yes? So here also voltage works, so during this period of time, yes? Here it works, yeah? So that's interesting. It means that enough voltage is not all the time, but only in shorter periods of time, for example. Yes? But when we have very fast changing of current direction, it means that we have high frequency. So we do not see the really turning on and turning off. Yes, we see it as a constant process of some device working. That's it. So it's important to know. Okay, and what we can see more. Yes, also when I told you about this RMS parameter, it's important to know that we have in our mains power at our homes, we have voltage RMS exactly 220 volts. This is our home circuit. So it means that we do not have the peak, yes, the maximum value of 220 voltage. It's only RMS. and we can count. We can count together if voltage RMS is 220 volts. So we want to count, for example, peak number, yes, peak amount. It will be square root taken of 2, yes, multiple 220. So how much it will be? Usually I take the square root as 1.41, yes, multiple 220, and I can use my calculator and count it. So no, it's not so easy to talk to you and to push the buttons. 220. So this amount, yes, will have 310.2 volts. Yes, so here is the peak number. So when your circuit will have this number, it's mostly okay. It could have it. That's it. But it is a peak. It means it's not the root mean square amount. Great. So we understood a little bit more about this peak parameter, and it is the same with the current. We can find the current. How can we find it? For example, we need to know the resistance of kettle. For example, let's take don't know exactly resistance of our kettles. Difficult to just invent something. Okay, let it be okay, let it be 7 ohm, for example. Yeah, it's just from my mind. I don't really remember the resistance of kettle. Okay, so we want and we can find the current flowing. So when we want to find RMS current, yes, it will be the Ohm's law, and we use voltage RMS divided by the resistance. That's it. So in our case, it could be 220 divided by 7. So let's count it. Yes, 220 divided by 7, and you can see it's 31 and 4, yeah, ampere. For example, that's it. Yes. And also we can find the peak current. Peak current will be with the same formula as for peak voltage, yes, connected to RMS. So it's square root from 2 multiple current RMS. Yes, so square root multiple 2, square root from 2 multiple 31.4. So let's do that, and that's just multiple 1.41. Yeah. 44 and 31. 44 and 31. So it will be the maximum, the peak current. Yes, so in amperes. And so for the current, it will be the same. The same graph, the same plot as for the voltage. I mean that it will look like sinus or cosinus. That's it. So here we are with main parameters, and then, for example, you need just to know how to count frequencies or time periods, and mostly that is all. But I want talk a little bit more, and I want to tell you how we can how we can produce, how can we get the alternating current. Yeah. So you can just look at me one more time a little bit. Yes. So I mean that alternating current coming because we have the connection between electrical field and magnetic field. It means that electrical field provides the magnetic field, and changing magnetic field can provide current. That's it. So that's a very, very important thing. And I also just just to make it more funny, yes, can show you some more formulas. Yes, you can see formulas with my tattoo. Yes, my tattoo is about Maxwell's formulas. So Maxwell wrote and discovered his formulas, and his formulas exactly told us about this connectivity. Yes, the idea that the electrical field creates the magnetic field, and changing magnetic field create the electrical field, and finally we have light. And light is exactly changing magnetic field and electrical field in somewhere in vacuum, for example, or in some other material. That's it. So here, so that's why here you can you can see sun. Yes. So I mean that if to dig deeper, we'll find some more funny details, but now we will talk only about how can we get the alternating current, knowing that we have this connection between magnetic field and electrical field. So if we have a conductor, for example, a wire, and we have a current, yes, running in this wire, so we will have a magnetic field. Yes, so B is induction of magnetic field. It will be around. Means that here it is forward. It's forward. Front part is front. Front. If to look at it as a 3D. And here is back. Yes, here is back. So it means that we have this direction. Yes, so when we come forward, it turns right. That's it. And that's very important and interesting thing. So it means that when we have the wire with the current, it creates a magnetic field around it. And we can make and have a wire like this. Yes, so for example, we have some tube, and we have a wire rounded it. Yes. Of course, it should be the electrical tube that do not conduct current. And here, if we will have, for example, electrical wire, let's make it like this. So this way, yes, this way. If we will have such current, if we have such current, we have this arrow which shows us magnetic field, B. So it means that when we have current which is rounded, we have just straight arrow, its magnetic field. So that looks similar, but a little bit different, yes. And we have this idea how we can find the direction, yes. So it's go forward and it will turn right. That's it. So exactly with this idea, we can build special generators, and we can say that here, yes, so B is a magnetic field, and also we can say that it's just a magnet. When we have magnet, we will have a magnetic field, yes, arrows coming from north, and they goes into the south. So it looks like that. So that's a magnetic field. Usually Faraday investigated. So Faraday investigated this process. And it means that here we can say that here is a magnet. Here is north. Yes, here is south. Yes, so it looks like that. And here we can draw small magnets. Yes, here will be north, south. Here will be north, south. Like magnets around the current. That's it. So we can, that means that we can use yes, wires, and we can use magnets to create an alternating current generator. So it can looks like this. We have, for example, two magnets. Yes, two magnets, and they created such magnetic field. So it means that here will be part of source. Here will be north. Yes, this is B. This B magnetic induction, and we put something like a frame of wire. We put into it, and this frame we can rotate it. Yes, and what happening when we rotate this wire? You can see when we have the frame, yes, stays like that, and the lines of magnetic field, so here is current, yes, flowing, and the lines of magnetic field are perpendicular, yes. So we have a maximum current in one direction. When we have frame just in the same dimension as magnetic field, we have zero current, no current. And when we, for example, yes, we rotate like this, yes, rotate it. When we rotate it another way, yes, so it's now looks like this, yeah. So we also will have current, yes, goes this way, but now that's that part, that is on the top, yeah. So here it was this way, and now it is this way, yes, you can see that. So the current changed its direction. And when we have these wires from this frame connected to other tools, so we can somehow collect and or just produce this alternating current. Not collect, I think, yes. That's it. And what more can I say? Oh, yes, I believe that's all. And also we can have not only the one frame of current. We can have, as we have more rounded, yes, a lot of rounds, yes. So we have can have a lot of rounds of wire here, yes. And this device is called coil. And when we want to, and we can change the amount of circles when we want to make, I believe, more current. I need to check it. One moment. Just look at it, at these coils one more time. Yeah. Oh, yeah, I have found it. Yes. So, yeah, that's it. Yeah, the amplitude, the amount of energy of alternating current. Yes, you can see this is my plot. If we want to increase the amplitude, we can make it in different ways. We can increase the numbers of rounds, or we can increase the magnetic field. Yes. So take a more powerful magnet, for example, or we can maybe we can rotate faster. Yeah, so we can change the situation faster. Maybe this, but I'm not sure. Um, it works with some devices, but yeah, we need to check it. That's it. So anyway, if you have more information about alternating current, I will be happy to listen to. And thank you for listening. Yes, it is long video and I'm really tired for today, but I'm alive, I'm happy, and I want just to feel this moment and to record my knowledge of alternating current because they are fresh for today. So thank you and goodbye.